Before we understand what the universe is hiding, we need to understand what we can see. The substance that builds planets, galaxies, even life itself. It seems ordinary, almost boring. But the matter is everywhere. After all, everything around us is made from it. The chair I'm sitting on, the screen you're watching, the air in your lungs, even your own body. Matter is so familiar that we rarely stop to ask that question. Why does the matter exist at all? Because according to the laws of physics, it shouldn't. Welcome to Makavora. I am Himant Prajapati, and together we are exploring the science and engineering behind everything. Let's get started. Imagine you are shrinking. It's smaller than a grain of sand, smaller than a cell, smaller than a molecule, smaller than an atom. The world is dissolved around you. What seems solid first now becomes almost empty. The atom itself is amazingly empty. Imagine a nucleus of an atom would be a size of a football placed center of the stadium. Then the electron would roughly orbit around the outer walls of the stadium, and everything center of the between is entirely empty. Yet somehow this emptiness creates mountains, planets, stars, and people. Inside this atomic nuclei, there are protons and neutrons, and within these particles, another layer exists, named quarks, nature's fundamental building block. These tiny particles combine together in different ways to create everything we knew. For centuries, humanity searched for the basic ingredients of reality. And eventually, scientists discovered that the universe behaved less like a machine and more like a symphony of particles interacting through invisible forces. But as scientists explore deeper into the microscopic world, they discover something extraordinary, and that is nature is possesses to mirror. The year was 1928. A young physicist named Paul Dirac was trying to solve a problem. The matter is, quantum physics described very small, Einstein relativity described very fast. Dirac wanted to combine both into a single equation. And what emerged was one of the most beautiful equations in the scientific history. But hidden inside this mathematics was something unexpected, something nobody predicted. The equation suggests that every particle should possess a mirror counterpart, an opposite version of itself. At first, it seems absurd. After all, nature itself seemed confusingly enough. But mathematics refused to cooperate. The mirror particles kept appearing. Dirac reluctantly accepted the conclusion. If this equation were correct, then somewhere in this universe there should exist an anti-electron. A particle identical to an electron in every way, expected one. The electric charge would be positive instead of negative. And 4 years later, this impossible happened. Scientists found it. An positron, a confirmed particle of an electron. Suddenly, scientists were forced to confront an entirely strange possibility. Perhaps an hidden universe, an hidden entire family of antiparticles, like anti-electron, anti-neutron, anti-proton, and eventually anti-atom, and more than that, an anti-world. Imagine holding a piece of matter in one hand and an antimatter in another hand. The moment they touch, something unexpected happened. Neither survive. Matter disappear, antimatter disappear. Both transform directly into a pure energy. Einstein's famous equation E equals to mc squared becomes the reality. Mass transform into energy with astonishing efficiency. A tiny amount of mass can release an enormous amount of power, and this process is called annealing. and it is one of the most violent event of nature. The universe appeared to treat matter and the antimatter like a cosmic oppositor, bring them together and they cease to exist. Now imagine the moment of the Big Bang. Yeah, exactly, the birth of space, time and life itself. Physics tells us that immense amount of energy filled a newborn cosmos, and from that energy, particles emerged. Matter, antimatter, again and again. By every reasonable expectation, equal quantities would be produced. And here's the biggest problem begins. Let's imagine two armies, 1 billion matter particles and 1 billion antimatter particles. They collide, annihilation begins. Matter disappears, antimatter disappears. Nothing remains, only the energy. No planet, no stars, no galaxy, and even no universe as we know it. And yet, this is not what happened. Because somehow, somewhere, something broke the summary. For every 1 billion antimatter particles in the early universe, there would be roughly around 1 billion and 1 matter particle. A tiny imbalance, a difference that seemed so insignificant. But after all matter and antimatter annihilated each other, this tiny surplus remained. Everything you see emerged from that disk microscopic advantage. Every planet, every star, every galaxy, every thought you ever had exists because matter won by that tiny margin. And still the question is, why? Scientists spent decades trying to answer this mystery. They experiments in particle accelerators, investigation on symmetry violations, studying on neutrinos, search for entirely new physics, all attempting to solve one mystery. Why does the universe prefer matter? And still, the answer remains unknown. And this mystery has enormous consequences. Because if our theories cannot explain why the matter survived, then our understanding of the early universe is incomplete. And somewhere inside this puzzle may lie an entirely new physics, new particle, new layers, or perhaps even a deeper layer of the reality we not yet discovered. But when scientists were struggling with the antimatter, a new mystery was already emerged. A mystery even larger, a mystery that cannot measured inside an atom, but across entire galaxy. Because when scientists calculated the amount of matter in the universe, the number refused to add up. Not by a little, but by a lot. The galaxies were too heavy, the stars were moving too fast, and the universe seemed to hiding an enormous amount of mass in it. A mass that nobody could see, nobody could explain. A mass eventually known as the dark matter. And that mystery is where our journey begins.